Welcome there, guys. We are going to look at the set interface, and this is also one of the interfaces in the collections framework. So a set interface is well known for not maintaining order of insertion and also for not allowing duplicates. So we have picked up three classes that I believe are most commonly used in the industry: the HashSet, the LinkedHashSet, and the TreeSet. And we're going to review the differences between them. So we see that a HashSet uses a hash table as storage, and a LinkedHashSet uses a hash table and a linked list. So it's a hash table and a linked list implementation of the set interface. Then a TreeSet is a navigable set implementation based on a tree map. Then we see that the HashSet does not maintain order, whereas a linked HashSet maintains order of insertion, and then a TreeSet sorts the elements according to some comparator. And we see that HashSet is better for performance than the other two. And linked HashSet, its performance is actually in between HashSet and a TreeSet. Almost similar to the HashSet, but slightly lower side, as it also maintains a linked list internally to maintain the order of insertion of the elements. And then the TreeSet gives the lowest performance than the HashSet and the linked HashSet, because it has to sort the elements after each insertion and the removal operation. The performance for the HashSet is big O of n for insertion, removal, and retrieval of operations, and the performance for linked HashSet is also big O of n for all the operations. But the performance for TreeSet is big O of log n, because of you know how a tree looks like, and you know that a tree has log n performance. Then a HashSet uses equals and a hash code method to compare the elements, and thus removing the possibility of duplicates. A linked HashSet also uses the equals and hash code methods to compare the elements. When you come to a TreeSet, it uses compare and compare to methods to compare the elements, thus removing the possibility of duplicates as well. So the reason it uses either of the two is because the objects that are in the TreeSet, you could find that they are either implementing comparable or comparator interface. So that is why we have that. We will look at the comparator and the comparable interface in our next upcoming lecture to see how they differ. Then you use a HashSet if you don't want to maintain order of insertion, but you want to have unique elements in the list. You use linked HashSet if you want to maintain order of insertion and also having unique elements in the list. You use TreeSet if you want to sort elements according to some comparator. That basically it with this element. So we can just review the code quickly. It's not going to be long. So I have a set demo class that I have put in place here. As you can see, the first is a list. Sorry, it's a HashSet. Second is a linked HashSet, and the last is a TreeSet. So we mentioned that the order here of insertion is not maintained. So basically, if I can just comment this code and run this code, we will see that we don't get the order in which we inserted the elements. We should have gotten 3, 4, 1, 2, 5, but we don't get that. That's what we mean by we don't get order of insertion, but it does not allow duplicates. So basically, if I was to have this, we will have 5 one time. It won't appear 2 times. That's what we mean. So I'm just gonna comment out this as well. So I'm gonna run this one here. So this one should give us the order of insertion, and it should also not allow a duplicate. We see that the order of insertion is maintained. So let's say here I have 0, for instance. You see 0 appears at the last one here. So that's it. So if I can comment this out. Now let's run this one here. So if we run this code, we have to get the order, because a TreeSet gives us the elements in order based on a comparator. So the question that you will ask would be, how does it know that 4 and 5, like 4 is greater than 3 and 5 is greater than 4? It's because an integer class implements a comparable interface, and a comparable interface has a method compare to. And if you look at the comparator, it has a method compare that has 2 parameters. So the reason this tree list knows that 5 is greater than 4 is because the integer implements comparable interface. Hence, you saw on the slides, we said that it uses compare or compare to. It just will depend the class, what it implements. That is it. So if you want to, that means if you have your own custom classes that you want to store in a tree, and you want to have that you want to maintain order. So let's just do that quickly so that we demonstrate. Let's just say employee class, and what we want to do here is we want to say private int h, and then what we want to do is to generate a constructor that takes that, to generate getters and setters. Then we want to generate the equals method and the hash code. Okay, this is fine. This is okay. So let's see what happens if we put employee here, and then what we do here is, we say new employee 3, okay, I'm just gonna add 3, 5. So if I was to ask you, what do you think will happen if we run this class? Just guess. Let's run it and you see what happens. So guys, when we run this code, we are going to have an exception. The reason for an exception is because, remember, the TreeSet relies on the compare and the compare to methods to compare elements so that it can sort them. So now it does not know how to do that, and you have not made your employee object to be able to do that. Remember that for it to know how to sort integers, because integer implements comparable. So what that means is that we need to implement comparable interface. Employee need to implement comparable interface. Even the error here shows that employee cannot be cast to comparable. So what can we do to solve the problem? Let's just come to our employee class and implement comparable interface. So we want to compare employee class. So we're not going to provide an implementation for now. So if we run this class now, we don't have any issues. The code run, we don't have exceptions. If we remove we undo our changes here, and we save our, okay, let's remove this method, and we come back. We see that here the construction of this TreeSet already is telling us there's a problem with non-comparable elements. So let's say that your class, you don't want your class to implement an interface, but you still want to have some form of, you want to tell the TreeSet how to order your employee, how to sort them. So let's run. We still have an error. So if you want to do that, you can pass a TreeSet a comparator. And now what a comparator will do, it will do the ordering for you. So what we can do here, we have created a class called compareEmployee. It implements comparator. Then we provide the implementation. So then you can pass the comparator to the TreeSet. Then it knows how to compare your employees. So if we run this class, it should be fine. So observe that the compare to and the compare method of the comparable and the comparator, they both return int. They both return an int. Yeah. And if you can read, they can either return 0, they can return 1, or they return some negative number. So that is, you see, 0, positive integer, as a first argument is less than or equals to or greater than for the second. So it returns negative integer, 0 or positive integer. We see that negative means less than, 0 means equals, positive means greater than. It actually the same even for the other interface. So that is what you have to do for your TreeSet to work.